DeepSeek V4 Pro, Kimi K3, and Qwen 3.8 are the three open-weight coding models everyone's trying to decide between right now, and I pulled every price, benchmark score, and deployment detail I could find to settle it. The surprise isn't which one is cheapest, it's that the cheapest one is also the fastest, which almost never happens in this market. By the end of this video, you'll know exactly which one to build your coding agent on, and which one only makes sense if money genuinely isn't the constraint. Let's start with the number that decides whether your monthly bill is manageable or terrifying. DeepSeek V4 Pro charges 0.435 per 1 million input tokens on a cache miss. Kimi K3 charges $3 a hour. Qwen 3.8 sits at $2 That's roughly a 7x gap between the cheapest and most expensive option, just on input tokens alone. Output pricing is where it gets brutal. DeepSeek V4 Pro is 0.87 per 1 million output tokens. Kimi K3 is $15. Qwen 3.8 is $6. Do the math, and DeepSeek V4 Pro is about 17 times cheaper than Kimi K3 on output, and still roughly 7 times cheaper than Qwen 3.8. Cached input pricing tells the same story, just more extreme. DeepSeek V4 Pro's cache hit rate is 0.036 per 1 million tokens, which is close enough to free that it barely registers on a bill. Kimi K3's cached rate is $0.30, and Qwen 3.8's is $0.25. For any agent that's resending the same system prompt or file context, turn after turn, that cache price compounds fast, and DeepSeek is in a different universe here. Here's what that actually means at scale. At 10 million output tokens a month, a real volume for a production coding agent, DeepSeek V4 Pro costs you about $8.70. The exact same workload on Kimi K3 costs $150. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. One community user reported running a full agentic task on DeepSeek V4 Pro for 6 cents total, and called it, in their words, mental value. DeepSeek V4 Pro wins this test clean. It's not close. That's not a benchmark. That's someone's actual invoice. I dug through official model cards, independent benchmark aggregators like Artificial Analysis and Goldie Bench, and community reported hands-on tests to build this comparison, so you don't have to cross-reference 9 different sources yourself. Price doesn't matter if the model can't actually write working code, so let's look at where these three stand on the benchmarks that measure real coding ability. On Terminal Bench 2.1, Kimi K3 leads at 88.3. DeepSeek V4 Pro is right behind at 87.9. Qwen 3.8 trails slightly at 86.6. That's a spread of 1.7 points across all three, which according to official docs and vendor reporting is close enough to call a three-way near tie at the top. Deep SWE is where the gap actually opens up. Kimi K3 leads with 67.5. DeepSeek V4 Pro sits at 62.7. Qwen 3.8 comes in at 56.6. That's a real, decisive difference, not a rounding error, and it shows Kimi K3's genuine strength on the harder, longer horizon agentic sweeps. There's a community-reported, not vendor, test worth mentioning too, a production-style software architecture evaluation, where Kimi K3 scored 83 out of 100, just ahead of Qwen 3.8's 80. DeepSeek V4 Pro didn't have a published figure for this specific test. One more data point that matters for context. On Goldie Bench's head-to-head scoring, Qwen 3.8 actually leads Kimi K3 22-17, which tells you these two are extremely close depending on which benchmark you trust. And Qwen 3.8's deep SWE score of 56.6 is worth flagging on its own. That's a massive jump from its predecessor's 21.6, the biggest generation-over-generation leap of any model in this comparison. Kimi K3 takes this test. It's a marginal win on terminal bench, but a clear win on deep SCWE and the architecture task, and that's enough to give it the edge on raw coding ability. A model that codes well but crawls through generation breaks the feel of an agent loop, especially when you're chaining calls together. According to artificial analysis, DeepSeek V4 Pro hits 89.7 output tokens per second, which is faster than that benchmark's own reported 71 tokens per second average. Kimi K3, measured on a similar harness, comes in at 40.8 tokens per second. Time to first token backs this up. DeepSeek V4 Pro can hit a 0.99 second time to first token on Together.ai's endpoint, community reported but unverified. Kimi K3 sits around 2.8 to 3.0 seconds. In a real agent workflow, firing off dozens or hundreds of calls, that difference stacks up into real, felt latency. Qwen 3.8 speed is a genuine blind spot. No published figure exists for its output tokens per second, and this is the one place in this entire script I'll flag that gap explicitly. That absence matters if you're planning to build on Qwen 3.8, because you're deploying without a speed guarantee. DeepSeek V4 Pro wins this test decisively. It's more than twice as fast as Kimi K3, and Kimi K3's slower generation gets compounded by the fact that it tends to use more output tokens per task in the first place, so the gap feels even bigger in practice than the raw number suggests. That's a 2.2x speed advantage for DeepSeek V4 Pro, and it's not a marginal one. Stick with me, because the last 4 tests are where this decision actually flips. Run a big refactor and hit the model's ceiling mid-generation, and you're stuck stitching together partial output. So this test matters more than people think. All 3 models are essentially tied on raw context window size. DeepSeek V4 Pro and Kimi K3 are both sit at 1,048,576 tokens. Qwen 3.8 is at 1,000 tokens. That's table stakes at this point. All 3 clear the 1 million token bar for long horizon agentic work. Maximum output per single response is where the real separation shows up. Qwen 3.8 can hit around 1,000. DeepSeek V4 Pro caps out at 384,000 tokens. Kimi K3 takes this test on the output ceiling alone. Most coding tasks never get close to any of these limits, but for the specific workflow of generating huge single-shot outputs, Kimi K3 has the clearest advantage of the 3. Kimi K3 can generate up to roughly 1,048,576 tokens in one response, community reported. That's still a genuinely massive ceiling, but it's nearly 3 times smaller than Kimi K3's. And if you're trying to generate an entire codebase or a very long document in a single pass, that's the model that runs out of room first. The best model on paper doesn't matter if you can't actually license and deploy it the way your project needs. DeepSeek V4 Pro ships fully open weight under the MIT license, which is about as permissive as it gets, 0 revenue-based restrictions. Use it commercially at any scale without renegotiating anything. Kimi K3 is also open weight, but under a custom license with revenue thresholds attached. Qwen 3.8's smaller 27B variant is open under Apache 2.0, but the larger Qwen 3.8 max weights simply haven't been released. Modality flips this. DeepSeek V4 Pro is text only, full stop. Kimi K3 and Qwen 3.8 both accept text, image, and video input natively. If your project needs any vision capability, DeepSeek V4 Pro is out of the running entirely, no exceptions. On API compatibility, DeepSeek V4 Pro natively supports the OpenAI Responses API and has been adapted for codecs. Qwen 3.8 Max speaks both OpenAI and Anthropic protocols. Kimi K3 is available through its own API and OpenRouter. This test is close, but DeepSeek V4 Pro wins on the strength of its license and broad API compatibility, both of which matter more for actually shipping something than modality support does for most coding-specific use cases. DeepSeek V4 Pro wins on price, and it's not subtle. 7 times cheaper on input, 17 times cheaper on output, and cash pricing that's nearly free. It's also the fastest of the 3 at 89.7 tokens per second, and it ships under the most permissive license available, MIT, with no revenue restrictions. Kimi K3 wins where the hardest coding work happens. It edges DeepSeek V4 Pro on deep SWE, 67.5 versus 62.7, and its near 1 million token max output gives it real headroom for generating entire codebases in one pass. It's also multimodal out of the box, something DeepSeek V4 Pro simply can't do. Qwen 3.8 is the balanced middle option. It sits between the other two on price at 2.00 and 6.0 Wern per million tokens. It's multimodal, and its smaller 27B model carries the most permissive fully released license, Apache 2.0. But it trails both competitors on the hardest coding benchmarks, and its speed numbers are simply unknown. For most people building a coding agent today, DeepSeek V4 Pro is the winner. It doesn't top every single benchmark. Kimi K3 edges it out on the hardest agentic sweeps, but it's 7 times cheaper on input, 17 times cheaper on output, and more than twice as fast. At scale, that combination is very hard to argue with. If you're running high volume, DeepSeek V4 Pro is your default. If you need the absolute peak reasoning on the most complex, trap-designed coding tasks, and the budget isn't a constraint, Kimi K3 is worth the premium. Qwen 3.8 is the right call if you want a balanced multimodal model with a fully permissive license on its smaller variant, but understand you're trading away some coding performance to get there. The winner here comes down to one thing: price to performance at scale, and DeepSeek V4 Pro owns that category outright. Here's what the marketing pages don't tell you. DeepSeek V4 Pro's headline pricing of 0.435 and 0.87 per million tokens is the standard rate, but on Artificial Analysis's reasoning benchmark at max effort settings, the real cost climbs to 1.32 and 3.96 per million tokens. That's still cheaper than Kimi K3 or Qwen 3.8, but it's not the number in the marketing copy, so if you're running max effort reasoning tasks, budget for the higher figure, not the headline one. If you want to see how these three actually hold up in real production conditions, hallucination rates, and overthinking on ambiguous tasks, that's the video to watch next.